welcome to this lesson on Pascal's triangle. It's a pretty exciting concept and relatively simple, and some of you may have seen this before. So it's a bit of a weird concept to start off with, but let's draw the first few rows of Pascal's triangle to see how it's developed. So first, you start with a 1 up top. Then you have a 1 and a 1 below. And then you have a 1, a 2, and a 1. Next row is a 1, a 3, a 3, and a 1. Next row is a 1, a 4, a 6, a 4, and a 1. And then let me explain how this is developing if you can't see it. So 1 plus 1 is 2. Here you only have one row that would head that way, or here you only have one that heads that way. For the next row, we would have here, so 1 goes this way. Then 3 is the sum of 1 plus 2. This 3 is the sum of 1 plus 2, or 2 plus 1. And then going this way, we have a 1. So try and fill in the last row there. So our last row here would be, here we get a 1. This would be the sum of 1 and 4, which is 5. And 4 and 6, which is 10. And 6 and 4, which is 10. 4 and 1, which is 5. And the last spot would be a 1. Oh, this is so much fun. Let's do one more of these rows. Try it out. Pause the video and see if you can do it. Okay, the last row is 1, 6, 15, 20, 15, 6, and 1. We can just keep going on and on and on. This triangle will never end. Pascal's triangle uses the following notation. In page 247 in your textbook, in section 4.4, has a really good diagram. So it uses this notation, T, N, comma, R. Those N and R are subtext. So the N is the row and the position is R, where we begin labeling with row 0 and position 0. So if we go up to this top triangle here, this would be row 0. And this would be row 1. Row 2. Row 3, and so on. The position number, let's pick a nice cool color for this. Let's go with black. That's not cool. Okay, the position, all of this right here is position 0. This is position 1. And so therefore, this right here would be position, let's write it down there, position 2. Okay, and we can keep going from there. Each term in Pascal's triangle is equal to the sum of the two adjacent terms in the row immediately above. So in the notation, T, N of R is equal to, and that's unfortunate, that showed up in the next line, so let's add it here. So T of N minus 1, comma, R. This is how you find out the next position. So for example, if we're looking at, let me grab my highlighter, this one right here. So this is row, what is this? This is row, so 3, 4, 5, 6. So this is row 6. In position, let's see, so this is 0, 1, 2, 3, 4. So position 4. So T of row 6, comma 4 is equal to T of N minus 1. So that'd be row 5 in position 4 minus 1, which is 3, plus T of N minus 1. So again, that's 5, and R, which is 4. So T of 6, 4, which we said was this one, that 15 there, is equal to the previous row, row 5, position 3 and 4. So Let me grab my highlighter here. So this is 0, 1, 2, 3. So we said it was position 3 and position 4. And yes, of course, that 10 and the 5 give us the 15 there. All right, let's try and figure out if there's some patterns we can find. So, and how to use this notation. So T30 is, let's see, so this is row 3 right here, okay, and position 0. So position 0 is that first spot there. So T of 30 is equal to 1. T of 5 comma 4 is equal to, so let's find the 5th row. So here's our 5th row, and we're looking for the 4th position. So 0, 1, 2, 3, 4, and that's the 4th position. So T of 5, 4 is equal to 5. All right, we're getting tricky here. T of 300 comma 300. All right. How am I supposed to know the 300th row? This is ridiculous. All right, maybe there's a pattern we can find. Let me grab this highlighter again. I'll change the color. All right. So we're looking at 300, 300. Well, maybe there's a pattern. Let's look at like T of 2, 2. So what would T of 2, 2 be? So T of 2, 2 would be right here, right? That's the second row in the second position where this is 0, 1, and then 2, right? So T of 2, 2 is equal to 1. What about T of 3, 3? Well, again, we'd go, this is row 3 right here, right? And this is 0, 1, 2, 3. And check it out, the answer is 1. And doesn't that seem like a pattern? The 5th row, 5th position would be right here. And so therefore, if we're looking at the 300th row in a 300th position, it would be equal to 1. That's ridiculously cool. Okay, what about T of 300 comma 1? Okay, T of 300 comma 1. There's got to be a pattern. So let's look at this first position and see if we can recognize anything in there. Man, this Pascal's triangle is getting messy, isn't it? All right, let's try that highlighter. Okay, what's the first position? So we went through this before. Here's our first position, and this row right here is our first position, okay? What do we notice? Well, row 1 here, position 1, the answer is 1. Row 2, position 1, the answer is 2. Row 3, position 1, the answer is 3. Get out. There's a pattern here. And what is that pattern? It's simply that the 300th row, first position, would be the row number. That first position is simply the row number. Awesome. All right, so those are those answers. So we're going to be noticing patterns today, okay, and playing around with patterns. And don't get too obsessed about getting the right answer right away, but just play around with the ideas. Okay, let's look at some other patterns we might notice in Pascal's triangle. So let's do the sum of the row to start off here. Sum of a row. So this is row 0, and the sum of the row is 1. Row 1, the sum is 1 plus 1, which is 2. This is row 1, I said, right? This one is row 0. Okay, what about the next one? Well, 1 plus 2 plus 1 is 4. And that's row 2. What about the next row? 1 plus 3 plus 3 plus 1 is 8. And that's row 3. Are you seeing a pattern yet? So we got 1, 2, 4, 8. Could it be 16 as the next answer? And you add it up. And yes, it is. And the next row is 32. Okay. So what is that relationship? Well, I'll stick with the blue. First row was 0, sum of 1. So row 0 was 1. Could it be that it's 2 to the power of 2 here for row 2, and 2 to the power of 3, and 2 to the power of 4, and 2 to the power of 5? And does that work over here? So we'd have on row 1, it would be 2 to the power of 1, which is 2. Oh, check. And here we'd have 2 to the power of 0, which is equal to, that's right, 1. So the sum of a row is 2 to the power of n, where n is the row number. That's cool. If you don't think that's cool, you need to figure out how to find some excitement in life, okay? All right, next one, the hockey stick pattern. All right, this is a good Canadian one. So what we're going to do is we're going to start at a 1, and we're going to head it down diagonally, and then we're just going to draw a blade going the opposite direction towards the interior. And what are you going to notice? Well, 1 plus 2 plus 3 plus 4 plus 5 is equal to, drum roll, 15. Okay, let's try that out in another spot here. So what if we start right here? 1 plus 7 plus 28. And then we head in the opposite direction. I said interior before, I mean in the opposite direction. So that would be 1 plus 7 plus 28 is it? 1 plus 7 is 8. 8 plus 28 is 36. Get out. All right, pause the video. Find a couple little other hockey patterns to make sure you're recognizing this one. It's cool. I like it very much. All right, natural numbers. So natural numbers are like 1, 2, 3, 4, 5, 6, etc. It does not include the number 0 because it's not a natural number. People don't use the number 0 when you ask the Smithville question of how many cows do you have. You don't say I have 0 cows. You don't use the number 0. It doesn't make sense. You say I have no cows. So natural is to speak in these numbers of 1, 2, 3, 4, 5, 6. And you will notice that on this diagram, the natural numbers are right here. Okay? So these right here are the natural numbers. And do you remember what position number that is? Think about it. Okay, it's position 1, right? Okay, what about triangular numbers? Well, first you better understand what a triangle is. In the past, if I had a class with me right now and I wasn't on a trip right now, I'd make you guys make a pyramid because that's super fun. So imagine making a pyramid with people, you know, where you're like on your hands and knees and someone climbs on top of you. So you could do a pyramid with 3 people. You could do a pyramid with this many people, which is 6. You could do a pyramid with how many is that? Well, that's 10 people. What would the next one be? Well, we would add on 5 to the bottom of that row, right? Which would give us 15 as our next number, okay? So do you see the numbers 3, 6, 10, and 15? Well, yeah, they're right here, aren't they? Okay. What about that 1 over here? Is that included? Well, imagine the loneliest pyramid in the world. You're just sitting there waiting. So that's a pyramid, 1 person. So that's a pyramid as well. And so you'll notice, if you keep going, that these are the triangular numbers. All right, this Pascal's triangle is ridiculously fun. I'm going to leave tetrahedral numbers up to you if you'd like to learn about what they are. It's a fun little change on it and see if you can understand the concept. But first look up what a tetrahedral number is and then see if you can find it on Pascal's triangle. The last thing I bring up is the quincunx. I don't know how to say that properly, but it's just a funny thing to talk about. We call it Pascal's triangle. I find it really depressing that oftentimes American or European concepts tend to just take over the whole world, and we tend to, I don't know, think that we know everything or that we came up with everything. Realistically, if you look in your textbook in section, what section are we in? 4.4, you will notice that the Chinese had come up with this Pascal's triangle here. So this picture right here was done in Chinese long before we ever even thought of it or Pascal thought of it. So the Chinese were using this concept a long time before Pascal. Okay? And I'm not even sure Pascal really developed it in European culture. I think he was just well known because he used it and was creative with it, and people just respect that. So, I mean, no loss of respect for Pascal, but at the same time, let's just recognize this was made long before Pascal, and that the Chinese had already conquered this idea long before he had come up with it and played around with it. Okay, so that is the end of this video, and you have some work to do based on Pascal's triangle.